Welcome to ABCDE Podcast. I'm your host, Joy San.
I am Lao Bai.
In this podcast, we'll be exploring the latest groundbreaking ideas, cutting-edge technologies, and game-changing development in a decentralized world. Welcome back to ABCDE Capital, episode 5. I'm Joy from ABCDE Capital, and today I'm here with two guests. I think most of our audiences are pretty familiar with our co-host, Lao Bai.
Hi, everyone.
And today we also have another guest, Tian Chen, CTO of Polyhedra Network.
Hi.
Welcome. The reason why I wanted to invite Tian Chen to our podcast is I wanted to know more about Polyhedra. Can you tell us a little bit about your background?
Yeah, I'm co-founder and the CTO of Polyhedra. My name is Tian Chen Xie. Previously, I was a PhD student in UC Berkeley, performing computer science in cryptography. So currently, I'm currently working in Polyhedra to lead the research and the technical team.
Yeah, just a little bit of quick question. Why do you want to co-found Polyhedra? What's the reason?
Yeah, let me talk about a bit history. So we started working on the ZK bridge since I think it's by the end of the 2021, because in August of 2021 there have been a lot of hacks to classical bridges. And at that point, my advisor told me that okay, you should look at this, and maybe zero knowledge proof can help reducing this security issue. Yeah, then we basically look at the bridge and it's for several months. I mean, after several months, we finally have the idea of ZK bridge. We started implementing and writing papers, and I think in May 2022 we submitted the paper. So that's why we start looking at ZK bridge. And the paper is actually accepted in September 2022. So that's why we publish our result in September 2022. Yeah. And after September 2022, we got some interest in actually making ZK Bridge becomes a product. So then we discuss, we develop, and finally in April 2023, we published the mainnet. Yeah.
Yeah, I was about to say congratulations on that as well. So can you tell us a little bit about like what are the advantages of ZK Bridge and what are the applications of ZK Bridge?
Yes. So initially, when you look at our story, initially it's trying to solve the security issue. So we think the ZK bridge is the most secure bridge. And after we actually develop the product, we have a very nice observation. It's that ZK bridge is actually can be a most cheap bridge. The user can pay lower fee because we can use zero knowledge proof to batch all of the transactions. It's like a roll-up fashion. User don't need to pay the full fee, and the user can amortize their fee among other users. Initially, the most important factor is security of ZK bridge, and afterwards we think that the most important factor is cheapest bridge. So that's two advantages of ZK bridge.
Yeah, that makes sense. And it's actually provide a efficient solution for the asset transfers and message passing.
Yes.
Something like that. Yes, totally agreed. And why are you interested in releasing the ZK bridge at this point of time?
Because it's just ready to get released at this point of time. And I think we can release it as soon as possible, because people usually say a system is secure or is robust only if they got used by a lot of people. And so when we release it earlier, we can get the We can get the system used by people earlier and fix some bug earlier. And we don't want to get into trouble when the system becomes a very hot topic.
That makes sense. Well, what are the partners right now for Polyhedral?
What do you mean by partners?
The partners means that people already using your ZK bridge, or like they want to establish the partnership with you.
Okay, I think the most notable partner is Layer0. They use our ZK bridge to secure their own bridge. Another most important partner is the Binance chain, BNB chain. That's the first. I think that's the first blockchain we integrated with. There are a lot of other blockchains already integrated with us. I think I can show the logo collection here.
15 chains already.
More than that, because this is
Right.
not updated.
Okay.
Yeah.
Yeah, Polyhedral is also in our portfolio. I believe in the long run, we can have like more resources provided to our portfolio and also have the synergies between the project that we invested. Yeah, cool. Laowai, do you have any questions regarding Polyhedral?
Yes, of course. Tianchun, I do have a few bit more technical questions I want to check with you. First is, how does Polyhedral use ZK Bridge to prove the full nodes of Ethereum POS? I think that's on July. You guys published the articles about full nodes of Ethereum POS. You guys using a dVirgo proving system, which always impressed me, even as the investors, because the performance is just way better than most of the other competitors. So I want to ask, how do you compare dVirgo with the popular options so far in the ZK market, such as Plonky 2 and some new stars such as like Nova, Supernova, Hypernova, etc.? Okay,
so let's go through it one by one. We prove the full node of Ethereum by using dVirgo, and it is very fast. It is very fast. It can achieve like 3 million constraints per second per CPU core. So to compare with, when you look at the Gross system, it can only achieve 1 million constraint per second, and not per CPU core. It utilizes a full CPU. So it's like orders of magnitude faster than Gross system. That's why we can handle this billion-size circuit in real life. In our actual development, we either employ like 1 or 2 very large server, or use 64 or 32 of small servers. In terms of proving Ethereum consensus, we need to prove like 20,000 or even 30,000 plus of BLS signatures in the circuit. This is very hard. When you look at older systems like Gross system, it takes more than half an hour. We developed dVirgo, and here the purple line is using 64 smaller devices in parallel to perform this computation, and the other line is using one giant server, only one giant server. So look at the time. It's only like 5 seconds or 7 seconds, depending on which hardware you use. People may ask, how small is the device? Because if people want to join our proof network, they want to get easy access to the hardware, right? This is our smaller device. It's a gaming console, and you can see my hand. So this is really small gaming console, and we use 64 of them to perform this computation. But for one prover, you only need to have one of them, and we can beat the other 63 of them on the network. So you don't need to purchase all of the machines. To compare with other proof systems, I think I need to pull some data from the internet. So here is data for Nova. When you look at the prover time, here K is the number of signatures or number. Actually, it's not number of signatures. It's smaller than signature. When you look at their proving time, when they dealing with like 10,000 signatures, they already become slow. Like 5 minutes, 6 minutes, or 5 minutes or 4 minutes. But it cannot match our performance.
I
So
see. They
yeah.
are more like a linear growth of the time.
this is still smaller than our circuit. It's only 10,000. We can prove like 3,000, 30,000 of signatures within 5 seconds. Server is actually similar in our Gent server. The Nova is actually way slower than us.
I think dVirgo is more like a sharding technology. It's like you can assign a huge proving jobs to different small devices or different cores of the CPUs and then
Yeah.
aggregate at the end, isn't it?
I would say, yeah, we assign the proving task to different CPU cores. And when you look at, there is a Plunky 2 benchmark. They have about 45 million constraint. And for this number of constraint, the Plunky 2 takes about hundreds of seconds on a Linux server. Hundreds of
Right.
seconds, yeah. And our size of constraint is about 1 billion, way larger than their size of constraint. So you can see the performance gap. We handle larger circuit and we are way faster than them.
If that's the case, since you guys already proved the full nodes of the Ethereum POS, would that match what Vitalik mentioned before in the roadmap of Ethereum, the fully snucked Ethereum in the final goal? That's like at least 3 or 5 years latest goal, or even longer. Can I say you guys has already achieved or partially achieved the goal using a different methodology, or maybe in my understanding that the fully snucked Ethereum should be not just the block header, should be every single transactions inside the Ethereum has to be snucked too. But polyhedgers mainly just focus on the block header ZK proof. I'm not sure which one is right.
I think you're right. Ethereum has 2 layers. The one is the consensus layer, and the other one is execution layer. So when you look at the execution layer, ZK snark it will be the ZK EVM, which already a lot of companies is working on. And when you look at the consensus layer, you make it a ZK. You use ZK snark to deal with it. It becomes a ZK bridge.
I see.
So, and you combine these two, you can make the whole thing fully zero knowledge proof. Yeah. So that's 2 separate parts, but we can combine them.
Right. So can we see polyhedra on the consensus?
Yeah, more on the consensus part.
More on the consensus, right? And the fully snucked Ethereum is more on the has to include the execution layer, which is ZK EVM.
Yes. When you combine these two, you have fully snucked blockchain, Ethereum blockchain. Yeah.
And also, I want to double check with you with another popular terms raised by Axiom, which is called the coprocessor. You must be quite familiar. And we've talked, we've talked to a few projects, including Axiom, and also another few projects using different terms for this called storage proof or state proof, like Lagrange, Herodotus, and even Seller. Mr. Dong is doing another project on this racetrack too. So I was wondering on 2 parts. First is technically, can Polyhedra do coprocessor jobs as well? And secondly is from the marketing perspective, would you guys go for that racetrack to compete with the names I mentioned before?
Oh, actually, I was a bit surprised by then, because the storage proof is actually a subset of ZK Bridge. We already implemented that since the beginning of our project. We're just focusing on the ZK Bridge part of it. So in our product, we already have storage proof, which is already used by our customer service. So when you think about ZK Bridge, we are relaying all the block headers through the ZKP generation, which is exactly what Axiom do. We store the block header on this updated contract here. And when you look at our customer service or working procedure, they are going to handle the missed transaction for users. So initially our RPC server is not so stable or not so reliable. The server may miss some transaction, and the user may report to us after several hours or even after several days. So in that scenario, our customer service team has to do a historical storage proof.
I see.
To retrieve like historical transaction for users like several days ago or several hours ago. So that's already being deployed internally in our team. And I think we have done like thousands or even more than 10,000 of historical proof. Because initially
Right.
our system was not so stable, and currently our system is stable enough. We don't need to do a lot of historical proof anymore. Yeah, I think we are more focused on the interoperability and real-time relaying of data.
Yeah, so that
So
means you guys can do co-processor anytime you want. It's just a matter of you want to compete on this racetrack or not.
yes, we can actually release our internal customer service part of our project anytime we want. But still, our engineer team is more focused on the bridge part, and I think it's like we don't have the capacity to start another project right now.
I see, I see. Or you guys, once you got time, maybe just open an API or a simple SDKs to make it looks like a coprocessor for the other project to use. Because
Yes.
coprocessor like giving me the history, a particular price or even a TWAP price of history time of a Uniswap for Ethereum. And
Yes.
then you do calculations. You guys can definitely do it. Just an API or SDK.
Yeah, we can modify our bridging API so you can request historical transaction at any time you want. Yeah, definitely we can do that. It's
Agreed.
so
The last things I want to ask you is about single slot finalities, which recently published by you guys, I think, last month.
here we go.
I just wondered what is that about, because that's like a huge concept for Ethereum.
Yes, so we observed that here we were doing like 32,000 of signatures in 5 or 6 seconds. And we were wondering whether we can do full Ethereum validator set, which has about 1 million signatures in terms of signature size. So let me give you some background on the Ethereum current implementation and how we are going to handle with it. So currently, assuming that these white dots are the full validator of have 1 million in terms of size. And current Ethereum will divide them into subgroups, 32 of them subgroups. Each subgroup will have like 20 or 30,000 participants. They call it slots. Each slot will have like 30,000 participants. So that's why when we talk about full node proving, we talk about 30,000 signatures. Each slot will be in charge of one block generation. Since there are 32 slots, they name this 32 slot as one epoch. So each epoch will go through the whole Ethereum validator set. And when you look at this, there has some problem. When you put your transaction here in slot 1, you cannot immediately confirm it because there is only like 32,000 validators signing confirming this block. And when you talk about Ethereum consensus, you always want a super majority of the validator set that's signing this block. So you need to wait until a sufficient number of validators has signed this blockchain, this chain of blocks. For example, if slot 3 signed this chain, then basically this means that these validators is agree on slot 1. So you need to wait until a sufficient number of validators or sufficient number of blocks has appeared here. In terms of epoch, 32 slot epoch, you need to wait at least 2/3 of the 32 slots, which means that you need to wait about 20 blocks to get confirmed, at least about 20 blocks. Actually, in most exchanges, they require like 70 blocks. So that's why this becomes a problem. You need to, the waiting time is too long for users to confirm a transaction. We think about this problem and we think, why do they need to divide people into several slots? It's because of networking overhead. It's very hard to gather like 1 million node into same slot. So that's why they divide it. And when you increase the size of the slot size, the P2P network just get too large to be sufficiently efficient. We introduce a ZK-based signature. That's what we do in the consensus proof. This ZK-based signature will become much smaller in terms of the signature size. How smaller? It's like hundreds of times smaller than original P2P network. That's why we can enable full single slot finality. We can invite millions of validators into the same committee, into same slot, and still get the P2P network working. So
I see. I remember Vitalik was mentioning about the possible solutions for the single slot finality. I remember he was proposing 2 or 3 different ways. In my memory, there are 2. One is, the problem is we can't aggregate like more than a few million BLS signatures because that's going to be too large.
yes.
So it's involved with the cryptography technology to have a better way to aggregate those BLS signature. And the second way is he's proposing a super committee, like a 500,000 or like a 300,000 validators as a super committee. And then as long as the super committee signed the contract or signed the signature, then we can consider this as a valid block. I think you guys tried to hack into the first way by not aggregating millions of BL signature, but using a ZK proof of these signatures and make the size way smaller.
Yes.
And trick the system so you can only just prove millions of ZK proof of the signature instead of the signature.
One proof. Single proof.
One proof.
Yeah, not millions of proofs.
Have you guys talked to Vitalik about this?
Yeah, we have very short conversation with Vitalik. So he has recommended some people to us that's working on this single slot finality. Yeah, we have several meetings afterwards with these people.
Okay, cool. Yeah, I would be super surprised or excited about if you guys can help Ethereum achieve single slot finality. Then there's the other chains that fighting on Ethereum, saying you guys are actually taking too long, taking 12 minutes to do the finality. Now, if it's 12 seconds, Ethereum will be a way better blockchain layer 1 than it used to.
Yes. So we are trying to do this. And this technology can not only be applied to Ethereum, but we can also apply to other blockchains. So it's the same concept, like aggregating validator signatures into much smaller proofs. That's same concept can be applied for every single blockchain.
I see.
Yeah.
That's
Oh.
very interesting. And in terms of like the roadmaps, not talking about the single finality, but in terms of roadmap, maybe this year or next year,
Uh-huh.
what are
Uh-huh.
the important achievements that Polyhedra wanted to reach?
Okay, so there's several stuffs. I think the most important stuff is we are working on the optimism chain to make it has a very fast finality. And so current older generation of bridging in optimism chain may require 7 days challenge period in to confirm a user transaction. So we are working on solving this issue by using our signature proving technology to invite thousands of validators to attestating this transaction. It's the same concept as single slot finality, but we are experimenting it with a smaller scale.
Does that mean that the challenge time will be sharply reduced
Yeah.
within? Okay, that makes sense. Any other interesting things?
We are also considering like open source, so not open our prover to the public. It's like next what the Stockware do. So it's still under development. I think it takes several months, 1 or 2 months to make a developer use our product or use our prover. So yeah, that's another interesting stuff we are currently developing. Because if we got more developer using our proof system, people may speed up the evolution of zero-knowledge proofs, because we are way faster. Then why not just let people use it? Yeah.
Yeah, that makes sense. One little heads up, like in terms of collaborations and also Polyhedra, what Polyhedra is doing right now is you guys are going to have a huge event in Istanbul as well, right?
We are
Yeah.
going to have a hackathon, and we are going to actually release a beta version of our prover to the developer, so they can submit their code and generate their proof in Istanbul. So it's part of the hackathon, and we are going to also release some interesting problems to the developers for them to solve.
Very exciting, very exciting. Looking forward to it. And ABCDE will also go to Istanbul as well. Hopefully we can host some events together.
Of course.
Yeah, great. I think it's almost about the time. And is there any last minute add-on you wanna talk about, or exciting news that you want to announce?
Yeah, so we are very, very excited to actually announce our full-node proving and fast finality for all of the blockchains. So just get ready for the new product, and the finality time, the latency will be significantly reduced by our product. Yeah.
Looking forward to it. All right, everyone. Thanks everyone for joining us at this podcast, and hopefully we can talk more about the Polyhedra in different occasions, and stay tuned to our Twitter as well as our Medium. Thank you very much.
Thank you very much.
Thank you. Bye.
Bye.